Hey, Forrest.
Hey, how are you?
Good morning.
Good. Okay. On LMS, we have the test scheduled for Thursday. Did y'all see that?
Yeah, top for me.
I have not the test yet. I posted it probably Thursday, but it's going to go through lesson 56. So the worksheet that we did 2 weeks ago. So today I want to answer any questions you still have about that. And then if we finish that, we can go on to our So, how do y'all feel about that test?
Ready for
Can
it.
we do 2 and 3?
Yeah. Okay. So, found it. I've got to get my phone out.
How is that? How's that test gonna work?
So it's going to look like a regular test. I'm going to upload it as a PDF. And I'll even leave space for y'all to work. So that you can print it out and work it on there. If you can't, you can just work it on a separate sheet.
Okay.
I would prefer y'all stuff to me as a PDF. I'm going to be grading. I know Riley did on that lesson. It was really easy for me to go in and work on it and show you corrections and all. The pictures are a little harder to do that with, but I'll take whatever you can submit. Just make sure you're doing your own work, because some of that stuff last time was not your own work. Yeah. So, your test needs to be your own work. There's going to be a section on there where you're going to sign off that you did all of your own work, which I realize some of you rely on that, and I hope you won't, but it is your integrity we're talking about. So,
What's integrity mean?
integrity, the right thing, nobody's listening. That's not a formal definition, by the way. That's,
Integrity is when you scream.
I'm not thinking so. All right, so
I like it.
whiteboard, and let's look at number 2. Yay. My whiteboard didn't work for my last class. All right, so number 2 says, Becca snipped square pieces of metal from corners of a 3x3 inch sheet of metal. So, hold on, I gotta get rid of my keyboard.
When you graded the review things that we did you like tell us if we missed one? Oh wait, yeah, you did. Never mind.
Was everybody able to find where I made the annotations?
How do you look at that?
You go back to the assignment, and where your work is, I posted on that. So you'll click on the assignment and you'll see your work, and you should see where I've submitted something to you. Okay. You should be able to get those and look through them. If there's something I didn't go over, ask me about it today, and that way you'll have the right stuff. All right, so she took out, this is going back to our problem, squares on both sides that are X, Y, because we're making a box again. All right, so when you fold that box, the height is going to be X. And then we took out 2 pieces. The sides are 3 minus 2X. Okay, does that make sense?
Yes.
Yes.
Okay, Sarah, you with us?
Yeah.
Okay. For some reason, your face disappeared, but I don't know why.
Oh, well, that's okay.
I think I see your face. Okay. Let's see what else it says. So we've got our box. She folded them up. Find the dimensions of the box of maximum volume, and what is the volume of the box. So to find volume, is length times width times height. So our height is x, and then our two sides are 3 minus 2x, 3 minus 2x.
Mhm.
We need to multiply all that out. 9 minus 6x plus 4x squared. Add like terms. Okay, are y'all with me on that's the volume?
Mhm.
Yes.
Okay, so then how do you maximize?
You set it equal to 0.
Set what equal to
The first derivative.
I heard paid, I think, derivative. So
Yeah.
let's do the derivative, v prime. We get 9 minus 24x plus 12x squared. And then we set x equal to 0.
Calculator it.
Yes, then you plug that into your calculator. And what do you get when you put that in your calculator?
1/2.
There should be 2 answers. 1/2 is one of them.
And then
3/2. Okay? Only one of those will be a maximum.
3/2.
All right, this graph looks like that. So the 1/2 is the maximum. The 3/2 would be the minimum. So to get the dimensions, I'm going to plug back to the sides here. So you'll do 3 minus 2 times 1/2. So 3 minus 2 times 1/2 is 3 minus 1 is 2.
Okay.
Our dimensions, this is A, are 2 by 2 by 1/2. Okay, and then your volume, I don't know why this didn't occur to me before, but you plug into our volume equation. But using what could we do? Anybody know?
What did you say?
So to get the actual volume with maximum, look at A, and we can use that to actually get the volume because the length, the width, and the height are all right there. So what's the volume of a rectangular solid?
1/2.
Is it just 2?
Yeah. So 2 times 2 times 1/2. 2, and I don't know what our units were on there.
Centimeters cubed.
That's a meters.
I think it's centimeters.
I don't know. I have to access it on my phone.
It's okay. We don't need it.
It's fine. All right. Does that make sense to everybody?
Yes, ma'am.
All right. Let me figure out how to. Ah, there it is. You said number 3 as well?
Yes, ma'am.
All right. The square is being enlarged so that its sides increase at a rate of 4 centimeters a second. All right. So we have our square with sides length of x. And then dx dt is increasing at 4 centimeters per second. All right, and then keep reading. It says, how fast is the area of the square increasing? So we're looking for dA dt when the sides of the squares are 2 centimeters. Okay. And then there's a second part, which is perimeter. We'll come back to that. So what is that area? This is the participation portion.
What did you say?
What is the form of the area?
Oh, length.
Yeah.
Sides
Oh,
of
I didn't
square.
know that's what you said.
Okay. If y'all can't understand, just let me know. So our area is side squared and our sides are x's. So we're going to do the derivative of our area,
2x.
dx, and then divide by dt. And then we're going to plug in what we know. So we get 2 times x is 2 times dx dt, which is 4. That's 16 centimeters squared per second. Okay, does that make sense?
Yes.
Okay, and then the second portion of that was the perimeter. So the perimeter of a square is 4x. So when we do the derivative, we get 4 dx. And then we plug in dx dt. Oops, I forgot to divide that one by dt. Dx dt is 4, so we get 16 centimeters per second. All right, what other questions do y'all have from this work? What about number 11? Did everybody get that one?
I didn't.
Okay, let me clear this and I'll go over it. Y'all use table on this. All right, so we have the graph of f prime. Okay, and it looks like that. We're at graph f. So what does it mean when the derivative is negative? Decreasing. And what does it mean when the graph f prime is positive?
Increasing.
Increasing, right. So on our graph, sorry about that line, at -4, we're going to decrease until that point, and then we're going to increase. Okay. How'd y'all do on number 14?
Don't remember.
Sir?
No idea.
Yeah, didn't get it.
I don't remember.
Not for us.
I did okay on 14. 15 was hard.
Yeah, can you do 50s?
I hope so. All right, let's see. 15 says b of x is equal to 2x cubed 6x squared minus 7. Use the first derivative to take the intervals over which g is increasing and where is it decreasing. So we need a first derivative. So we get 6x squared plus 12x. All right. And then we need to know where is that 0. We can factor the x out. So when is x 0 and when is 6x plus 12 0? Okay, so there's 2 places where it's 0. So if we look at our x graph, we have a 0 at -0.5, and we have a 0 at 0.
Or -2.
Oh, yep. You have to figure out how to erase. There you go. Thank you. I don't know why I couldn't divide evenly or correctly. There we go. All right. So we are increasing, decreasing, increasing. Yes, no?
Yeah.
So the intervals we are increasing is from -infinity to -2 and from 0 to infinity. And then we're decreasing from -2 to 0. Okay. You could also do that if you thought about like a number line. And you can pick, say, a number like -1 that's between these two and plug it in to your G prime equation. You get 6 times -1 squared plus 12 times -1. So 6 minus 12 is -6. So since that came out negative, that section is decreasing. You could also do a number down here in the negatives and one over here in the positive, and you should get positive numbers. Okay? I don't care if you use the graph like I did up here or if you use a number line like this. Either one, whichever one makes sense. All right, and then the B portion of that, it says use the second derivative and state the intervals over which B is concave up and where is it concave down. So let me get rid of a lot of this. I should have kept that derivative. Do better at racing my board at school. So look at the graph that I drew up there, and you can see where it's concave up and where it's concave down. Is the graph concave up or down first?
Concave up.
This portion, what is it?
That's concave up.
No.
Concave down.
Right. If it looks like an umbrella, it's concave down.
Got it.
The bowl is concave up. Okay. So there's one section where it's down, and there's one section where it's concave up. We need to know where is that point. What do we call that point?
Inflection point.
Yes, an inflection point. So we need to find that inflection point. So I erased my first derivative. I've got to get it back. All right, and then we do the second derivative. All right, and when is that equal to 0? Okay, so our inflection point is so we're concave down from negative infinity to -1, and we're concave up from -1 to infinity. Okay, you could also put in a number, like I could plug in 0 to my second derivative. If 12 is positive, anything from -1 up would be in your concave up section. Okay? How's it? I can only see a few of your faces. Oh, now I can only see them. Interesting.
I got it. Easy.
Okay. I can only see the ceiling. All right. What other stuff y'all have questions on this study guide?
Can you do 14?
Mm-hmm. All right, differentiate. We have the ln sin x. Is that value plus secant to x? Sorry, I couldn't read my own worksheet. So we've got two pieces here that we have to use the chain rule on. So we start with ln. What is the derivative of ln?
1 over.
So it's 1 over sin x. Okay, and what is the derivative of sine x?
Cosine x.
Right, so it's 1 over sine x times cosine x. All right. And then what's the derivative of cosecant?
Is it negative cosecant?
Cotangent x.
Yes, negative cosecant cotangent. So negative cosecant. Now what goes next to the cosecant?
2x.
Right. A few of you left that out on the worksheet, so make sure you keep what you're taking the cosecant of. Cotangent. All right, now then what is cosine over sine?
Cotangent.
So we get cotangent x minus cosecant 2x cotangent. I don't know why I put a parentheses there. I'll get rid of it just a second.
Wouldn't you do the derivative or the 2x on the inside? Or no?
Thank you. And then times the derivative of 2x, which is 2. I gotta move y'all. Sorry, I got distracted. All right. And then that's all you can do to that one. There's no other pretty enough you can do. Well, Conley, you got any questions? No. Let's see. Who else have I not heard from? Riley, you've got it?
Yes, ma'am.
Taylor, you good? Susie? Lindy, Lily, 5, 8,
Can you do 8?
8? Yes. Y'all know I've missed doing math, right?
Oh yeah, of course.
It's sad, I know, but I have. All right. I've really missed the teaching part and getting to interact with y'all, but I like the math too. The radius of a spherical ball is expanding at a rate of 5 centimeters per second. So DRD is 5 centimeters per second. How fast is the surface area of the ball increasing? So what surface area is increasing, and the radius is 10 centimeters. So what is our surface area formula?
Is it 4 pi r squared?
Yes. Okay. So then we do the derivative of it. We get dA dt. 2 times 4 is 8. Pi, subtract 1 from the exponent, dr dt. All right. And then we can just plug in everything we know. We get 8 pi times 10 times 5. That's 400 pi centimeters squared per second. Okay. Oh, look, you got your dog. I'm not going to mess with him.
Is that the answer?
That is.
Okay, can you do number 6 as well?
Huh? Somebody just popped up the chat box. I can't see it. Was it directed at me or somebody else?
Somewhere else.
Okay. So I'm probably glad I don't see it.
Can you tell me what the answer was to one? Because I did it, but I didn't get it right.
Okay, so again,
Will you tell me what the answer is to 1? Because I did get it right, but I don't know what the answer should be.
they may have the answer in front of them because I don't.
I think
Number
it's
1.
square root 5 units per second.
What number is that?
1.
Number 1.
Okay, so I'm going to do number 6 and then I'll go back and do number 1, okay?
You shut up, man.
Sorry, I was caught up on your chats. It popped up again. All right, so use implicit differentiation to find y dx. Is that an x cubed? Yeah. Minus 3x sine y. 5y squared. All right, so we've got implicit differentiation. So remember, that's where we put the dy dx after it. Dy or dx, excuse me. So the derivative of x cubed is 3x squared dx. And then we have to do the product rule. So we're gonna the negative 3x as one there's one factor in the sign. So we bring down the first term times the derivative of the second term. So derivative of sine is cosine dy, cosine y dy, plus then you bring down the second term, sine y, times the derivative of the first. So derivative of negative 3x is negative 3. And dx. I didn't move y'all. All right. And then plus, ooh, we're going to ignore that mark. Plus the derivative of 5y squared is 10y dy. And the derivative of 0 is 0. So far, so good? Okay, I didn't hear anybody say no. So keep going. All right, then we want to, we're solving for, what are we solving for? Dy dx, so we need to divide everything by dx. All right, so dx over dx is going to cancel. And then I'm going to group everything with a dx together. So 3x squared and minus 3 sine. All right, and then minus 3x cosine y dy dx and plus 10 y dy dx. Okay. And we want to solve for dy dx, so I'm going to bring the dy dx's to the right. So I get a positive 3x and a negative 10y, and I'm also factoring the dy dx out. And then we divide by what's in the parentheses. Okay, does that help?
What happened to the cosine?
Up. Give me just a second, he'll show up again. I honestly don't know what I did with the cosine. Sorry about that. So I get 3x cosine y minus 10y. Hold on a second. Is that better? Mm-mm.
So is that the answer?
Yes.
Okay.
Okay. So Riley, y'all need to go to your next class to physics, I think.
Yes, ma'am.
But I will work out number 1 and post it to the class wall for you.
Okay, thank you.
No problem. All right, y'all have a wonderful day. And it was good to be able to see y'all again. And we'll do it again tomorrow.
Thank you.
All right. Bye, guys.
Bye.